Mukund, shall we start? Hello. Okay. Good afternoon to all present here on virtual dais. Dr. Sanjay Khot, Principal, Sharad Institute of Technology, College of Engineering, Yadrao, Itzalkarji, Kolhapur. Honorable Principal, Dr. Sanjay Bokade. Vice Principal, Dr. Sanjay Deshmukh. Head of the Department of Mechanical Engineering, Dr. Rajesh Ray. Head of the Department of All Disciplines, teaching and non-teaching staff, and all the participants. I, Ravindra Kurne, Associate Professor in the Department of Mechanical Engineering, on the behalf of Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, welcome you all for the first day of second session of AICTE AQIS sponsored online 1 week STTP on recent trends in energy management and audit. Today we have Sanjay, resource person for this STTP. We will speak on Introduction to Energy Audit. I take this opportunity to introduce our today's resource person, Dr. Sanjay Khot. Sir has completed ME Power Engineering from Walchand College of Engineering, Sangli, PhD from Shivaji University, Kolhapur. Sir is having total 33 years of experience. He is certified energy manager and auditor, BE New Delhi. He is a life member of ISTE and ISHRE. He is also life member of Indian Association of Energy Management and Professionals, Bhopal. He is empaneled as an energy planner and energy auditor, Maharashtra Energy Development Agency, Pune. Also, he is empaneled as an energy auditor, Sugar Commissioner, Pune. He is a member of NAC Peer Team Committee appointed by NAC Bengaluru. He is a resource person for NBA and NAC. He has worked for external academic monitoring, curricular revision.
Sir, make it brief, just.
Project. Okay.
Break
okay. He is a board of studies for automobile engineering. He is a reviewer for 2 international journals, Clean Technologies and Environmental Policy, Springer, International Journal of Automotive and Mechanical Engineering. He is a recognized PhD guide at Shivaji University and Dr. Babasaheb Ambedkar Technical University, Lonere. He has published 6 papers in national journals and 11 papers in international journals. Now I request Dr. Sanjay Khot to start his session. Over to Dr. Sanjay Khot, sir.
Thank you. Thanks for your kind words. Just I will share my PPT. Okay, PPT is visible. You can see my PPT. Hello.
Yes, sir. Yes, sir. It is visible.
Okay. Good afternoon, respected Principal, Rajiv Gandhi Institute of Technology, Mumbai, respected Vice Principal, Dr. Kale sir, HOD, Head of the Department. On behalf of our institute, Sharad Institute of Technology, College of Engineering, I thanks all the organizers for inviting me to deliver lecture session on Introduction to Energy Audit. So total outline of my talk would be like this. I will start from the energy scenario, then installed capacity in India, Energy Conservation Act 2001, Energy Conservation Scheme under Energy Conservation Act, Energy Audit definition types, detailed energy audit, 10-step methodology as recommended by Bureau of Energy Efficiency, and I will share one case study of one of the engineering college so that you will get feel of a energy audit, and then question answer session. Now, total, if you compare the our energy scenario as compared to the world, our population among the total world around 700 crores of the population, more than 700. The total share of our India is a 17%. But if you compare the share of all the resources as compared to the world, we are having only gas resources of 0.6%, oil of 0.4%, and coal reserves are only 7% as compared to the global reserves. And so we can say it is India is poorly endowed with the energy resources. And even it has been estimated by the different researchers, or it is available through the government data. India's oil and gas reserves are estimated to last, it is going to deplete within 17.5 years. This is for the oil, and gas would be for the 40 years respectively. And at the same time, coal will be there maximum up to 100 years. This is what the projection as per the available resources and at what rate we are consuming all the types of this were fossil fuels. But it may this data or these years may get reduced because the consumption has increases yearly. Now we'll see the total installed capacity. This data is as on 31st March 2020. Now if you compare the latest data from the Ministry of Power, the total installed capacity has gone to 372 gigawatt. So this is the total installed capacity in India. It has a 370 gigawatt. Now we'll see the contribution of the different types of the fuels, how the energy, that is, we'll focus here only how the electricity is being generated by the different sources. So first and main prominent source is the thermal, that is a fossil. So the total electricity generation, this is the installed capacity by the thermal, it is around 230 gigawatt. So the total percentage comes to be a 62.8% against total 100, that is 370 gigawatt. And again, if you compare under this your thermal, there are three major. One is coal, gas, and oil. And again, under this coal, gas, oil, coal is contributing around 55.9%. And fortunately, that India's coal reserves would be up to 100 years. So we need not bother that much about the gas and oil as far as only electricity generation is concerned. Now, second one is the renewable energy. Earlier, the second type was the hydro, but because of the government initiatives, since that is by the every government, now that contribution has gone up to 23.5%. And at present, installed capacity of all the renewable, maybe solar, wind, and other types of the small, all the renewable, it has gone up to the 87.3 gigawatt. This much is the installed capacity of the renewable energy. So this is the second. Third one is the hydro. Now the total percentage of installed capacity by hydro is 12.4%, and gigawatt capacity is 45.7%. It is third. And next one is the nuclear. So the nuclear percentage is only 1.9, and gigawatt it is a 6.78. There is a scope to increase this all this nuclear power plant in India, but there is only fear because of that your hazardous disposal of this your nuclear waste, and because of there is a restriction ban on to increase the capacity of the nuclear because of that safety issues. So this is about the total installed capacity in India, and it doesn't mean that all 370 gigawatt is working at all the times. There is issue for the power factor issue. Plant load factor is one important. Other one is about the nuclear, the renewable, when the solar is available, when wind is available. Hydro, again, that depends on the availability of water. Nuclear, again, that depends on the permissions from the central governments to start to run that kind of this types of the power plant. So it doesn't mean that all the 370 gigawatt capacity is generating electricity at a full capacity. So always for the thermal, that plant load factors are very small. Again, that depends on the type of the power plant, whether it is old or new, or the efficiency. Now again, if you compare our Maharashtra, so installed capacity of the Maharashtra is only, it is around, here we can't use even the gigawatt, it is only 13,817 megawatt, or we can say it is just 13 gigawatt. This much is the installed capacity of the Mahajanko. No doubt, other than this Mahajanko, that is a government of Maharashtra, there are some private players which it has been counted in the total installed capacity. So again, if you compare this your install capacity of the Maharashtra, so here thermal power station, again that install capacity is around 10,380, that is a 10 gigawatt. Now another one is gas turbine power station, it is 672 megawatt, and hydro we have 2,585 megawatt. And last one is solar, this is 180. Now this solar 180 means this is the ownership of this your Mahajanko. Earlier, always we used to say that this is MSCB, but it has been divided into three parts. So first one is the Mahajanko, where which takes the care of the electricity generation to increase the generation capacity, make available electricity at a lower cost, at the same time with less affecting on the environment. Second one is the transmission. It is called as a Mahavitran. That means electricity produced, it transform electricity from the Genco up to the distribution, and last one is the distribution company. Now, if you see the requirement, energy requirement, and we'll have some projections. These projections come up with some researches. That is how the developments are taking place in India, as well as how the effect of the global on the Indian environment and everything. So when that during the independence, that install capacity was only 1,362 megawatt. Now by 2017, it has reached to 3,50,000 megawatt. At present, just we have seen by 2020, it is around 370 gigawatt or 3,70,000 megawatt. And it has been projected that because of the urbanization, because of the globalization, or because of the increase in the economic status of the human beings, or the requirements because of the gadgets, so many equipment appliances are coming in the market. So by 2030, it would be around 7 lakh megawatt. This much is capacity required. And as at present today, we have only 3,72,000 megawatt. This much is available, and almost double is required, and that too by 2030. And even suppose government has decided to start any install and commission that thermal power plant or hydropower plant, it need around 5 to 7 years to start all these things. And again, concern is about the resources required for the thermal as well as for the hydro. So what is the next solution to overcome all such a problems, or to reach to this the requirement by 2030? Now that we'll see by the energy pyramid, how to conserve that electricity, or any this energy means we are talking about electricity as well as all other types of the energies, that includes the fossil oils and other, wherever that energy is required. So for that main important is the energy conservation. Wherever it is possible, without disturbing the human comfort or the industry's requirement, wherever possible, you can conserve the electricity. That means if you conserve 1 unit of the electricity, that means it is as good as we have produced 2 units of the electricity at a generation level, because there are always losses for this your generation levels, losses in the transmission, losses in the, even if you compare, because all we are the technocrats or engineers, we know that the efficiency of the thermal power plant lies between 30 to 40%. Somewhere it is 45%, somewhere it is 25%. That means whatever fuel we are burning in the thermal power plant, it will convert only around 30 to 40% in terms of the electricity. That is the major loss took place in the thermal power plant. Again, whenever that electricity transmit from this your generation point up to the distribution through the different cables and lines, all the different lines, there that losses are around the 17 to 18%. Again, when that electricity reaches to the distribution, and from the distribution it is being distributed among the different types of the consumers, it may be the industry, agriculture, or commercial and the residential kind. There are different categories where again there are the losses. And if you take the case of the example of the motors, because major the electricity in the industry is being utilized or consumed by the motors also. Again, motors has the efficiency, there again the loss is there, even fan, so many, whatever the appliances are there, everywhere there is no 100% conversion of this electricity into other form. So there are so many losses. So we need to emphasize more towards the energy conservation by taking utmost cares of a reduction or consumption of this your electricity. And the common tips for that is, at least whenever there is no any requirement of the tube light span, even we'll take examples of our college laboratories, immediately we should switch off the fans, tube lights, and all the different appliances wherever they are not required. Whenever we go out of the class, that is, it happens with the classrooms as well as the laboratories, or even whenever even at your places, that is more use of the air conditioners are there. So in air conditioner, with no doubt for the comfort condition, that condition is that is 24 degrees Celsius temperature, that is drivable temperature, and relative humidity should be around 60%. If you increase the temperature from the 26 to 27, 24 to 25 degrees Celsius, with 1 degree rise in the temperature, you can conserve the electricity by 6%. Now, as per the government of India norms or the guidelines, even the government of India release guidelines through the ICMR about the how to use the air conditioner. There it is advised that you should go up to 27%. That means from 24 to 27, 3 degrees Celsius rise means around 18% of the electricity you can conserve, and that will not affect on the comfort of the human beings. Because what happens, we are reducing the temperatures and using blankets at the room or at the hostels wherever is possible. So that is one tip. Wherever possible, you have to conserve the electricity. So this is the major portion of the energy conservation. Now next is, once the energy conservation is over, that is you reach to the saturation, then immediately you should think about the energy efficiency. Now in this your energy efficiency, main theme for this your energy efficiency is without disturbing output of that appliances. Output would always remain same, but only the change is towards the input. That means you can reduce the consumption, or you can devise different types of the appliances or the motors which will consume less, but which will maintain the same electricity, same output at the other end. So there are so many appliances in the market. So you should focus, or while purchasing appliances, you should go for this your such types of the energy efficient appliances. For example, common is your LED bulb. Because earlier we were using incandescent, then CFL come. Now LEDs are there market. Now still new innovation is going on. Everywhere the lumens output remains same, but input has gone reducing at every places. So this is happened with the electric motors also. Now the motors are nowadays specified in terms of the I1, I2, I3. That is international efficiency 1, international efficiency 2, 3. Now there is ban on the international efficiency 1 also. Now 2, 3. Like that, you should select whenever you go to the market. Always you should emphasize towards the energy efficient appliances. So this is the second type. And last one, you can think about the renewable. Whenever there is a saturation of energy conservation, energy efficiency, then you can think about the go for the renewable energy, that is installation of the solar PV system, wind system, and other, there are biomass, biogas, so many other the sources where you can generate the electricity. So this pyramid is very, very important. And as you go on in this pyramid, automatically the release of carbon gets reduced, or we are reaching towards the zero carbon release. Now, what is the solution? What government is doing for that? So government of India has enacted one law, that is Energy Conservation Act. It is called as a 2001 because it is acted on the during 2001 in the parliament session, and that to provide legal framework and institutional arrangements for enhancing energy efficiency. So major emphasis of this Energy Conservation Act was to enhance energy efficiency everywhere. Wherever there is a possible, you can enhance the energy efficiency. And because of this act, actually the birth of Bureau of Energy Efficiency took place. Now because of this your Energy Conservation Act, at central level there is one Bureau of Energy Efficiency, one is statutory body which take the decision, which work as the nodal agency at a central level, and through that your Bureau of Energy Efficiency or the nodal efficiency at nodal agency at every state, there are the state designated agencies. Now for Maharashtra, it is the MEDA, Maharashtra Energy Development Agency. For the Karnataka, it is KEDA. For Gujarat, it is a GEDA. Like this, every state, they have their separate, the state designated agency. And through this your state designated agency, all the requirements of this your acts are being implemented, or it is being passed through this your this DE to the state nodal agency. So what is the main important schemes? What are the main different schemes under this your Bureau of Energy Efficiency, or that is under the Energy Conservation Act, which is being done, implemented by the BEE? So first one is the Energy Conservation Building Codes. You might have heard the launch of this your code by the central minister, as well as it is being in the process of the state government also. Anytime state government will release this your Energy Conservation Building Codes. So now again the central government has started. This is especially for the commercial building, ECBC. This is for the commercial building. Now government of India has prepared draft code for the residential building also. within 2-3 years, that code will be also in the place. Earlier, this your ECBC code was a voluntary code. Nowadays, hence the state government, whichever accept this code, from that date onwards, that buildings must comply as per this your energy conservation building code, because that is a separate entire topic we need to discuss. 1 hour we can discuss on this your ECBC code. So this is only for the commercial building having connected load more than 100 kilowatt or 120 kVA. There this load is applicable for all the new buildings. Next one is the standards and labeling. So this your standards and labeling comes for the energy efficiency. Now government of India has insisted all the manufacturers what to manufacture, because whenever they want to manufacture any electric appliances or energy consuming appliances, there are some standards. That means that particular machine, particular motor, particular tube light must produce this much output at particular input. So that is the first standards laid down by the Bureau of Energy Efficiency as per the guidelines of the Energy Conservation Act. And on the basis of the standards, they have prepared the labels. So you might have seen the star label 1, 2, 3, 4, 5. There are 5 stars. So whenever we go in the market to purchase any appliances, that is energy intensive appliances, we should focus towards this labels. Once that label is higher, that means that product is energy efficient product, or it is consuming very less amount of electricity. So that itself ensures you need not bother about all other things. Just you should check the validity of that labels. Because every year what happens, whenever there is an upgradation in the star label, suppose for this financial year, if the 5-star is for the LED tube light, next year this 5-star guidelines would be for the 4-star. Because there is a continuation innovation in the market, in the industry. Every industry is trying to bring new product with a less energy consuming product or more energy efficient product. Now third one is the demand side management. That means wherever there is a demand is from the textile industry, demand is from the manufacturing sector, demand is from the agriculture sector. Wherever there is a demand, there you have to manage. So that demand side management is one part which come under the Energy Conservation Act. And there you can manage, because electricity available at night time is at a less rate tariff as compared to the daytime. So there also at the industry level, they can manage their demands. By that, the requirement of electricity get reduced during the peak hours. So that is also one part which come under the Energy Conservation Act. Another one is the promotion of energy efficiency in small and medium enterprises. This SME enterprises in Indian industry, it contributes around 40%. So 40% of the industry, manufacturing sector come under this your SME. So here government is insisting to go for the energy efficient all the appliances, that is the motors, fans, air conditioner, whatever the equipments, appliances they need. So that it comes under this word energy conservation. So government is promoting them with the help of incentive, with the help of some rewards, or so many times they are giving the fundings to them at a subsidized rate of interest. So that is one. And next one is the designated consumers. Government of India has identified the list of the energy intensive industries. For example, paper and pulp industries there, cement industries there, steel and iron industries there, sugar is there, textile is there. Even they introduced a commercial building. So there is a 15 categories, different categories of the building. That number is on increasing, and they have analyzed, studied the energy consumption pattern, because these all are the energy intensive industries. So they have studied, and on the basis of their consumptions, they have identified the benchmarks. That means particular cement factory, how much energy consumption or energy required to produce 1 bag of the cement, or how much is electricity required to produce 1 kg of air. So like that, they have optimized that requirements and they put it as the benchmarks. And every year they are giving some promotional benefits to this your industry, and this particular industry must comply these standards. Otherwise, there would be fine to that particular industry. Or if suppose some industries are using less electricity than the benchmarking consumption, then they are getting some rewards also from the Bureau of Energy Efficiency, or they can sell it. They call it as the cards. They can sell that electricity cards to the others also. And last one is, this is very important for all the teaching as well as student fraternity. So as per the Energy Conservation Act, there is a new provision of the certification of energy auditors and the energy managers. So there are total 4 subjects. If you qualify first 3, you become an energy manager. If you qualify the 4th one, you become a energy auditor. So that also you can go through the website, you will get the curriculum and all these things. Now next we'll see that is about the energy consumption by the building. Energy consumption by building. Now this is because I'm going to share one case study related to this university. So here what happens, or this is the study, what reveals the study that building consumes about 1/3 of the total annual electricity energy requirement. So whatever the all over India, the electricity requirement is there, against that 1/3 of the electricity is being consumed by the building category. Again, buildings are divided into two. One is the commercial sector, another one is the residential sector. And this your commercial sector consumes around 8% of the electricity against that 1/3. And the residential sector is consuming around the 25% sector. So because of that, government, as per this your Energy Conservation Act, they have launched the 2 different types of the code, ECBC for commercial building and ECBC for the residential, which is in the draft stage. Okay, and this is one of the largest contributor of the greenhouse gas emissions, because 1/3 of electricity is being consumed. That means that much amount of carbon dioxide is being released. And another study shows, as far as a commercial as well as a residential building, is that around 70% of the building stock required by 2030 is yet to construct. So why not to construct such buildings using this your ECBC Act or the compliance, so that while construction itself we can take care of consuming less amount of electricity for that your building, electricity or other form of the buildings. Now we'll shift towards the main our topic, that is introduction to energy audit. Now there are different definition of the energy audit. As we are focused towards the Energy Conservation Act, or we want to conduct the energy audit as per the Bureau of Energy guidelines, so we must strictly follow the detail, that is energy audit, comprehensive energy audit defined by the Bureau of Energy Efficiency through the Energy Conservation Act. So as per this your EC Act, energy audit is defined as the verification, monitoring and analysis of use of energy. Now this use of energy may be electric, energy may be thermal, energy may be any other kind of the form which is being used in the industry. But major 2 forms of the energy are being used in the industry or in commercial, even in residential. One is electricity and other one is the LPG gas we are using at our industry, and coal, firewood and others are being, that is thermal category, it is being used in the industry. So here we have to do analysis of what type of the energies are being used in that industry. That analysis that you can do after verification, monitoring. So you have to make verification as well as you have to monitor the consumption pattern of that particular types of the energy. And after that you have to submit a technical report, and that technical report must contain a recommendation for improving energy efficiency. That means, suppose if you observe number of the appliances are energy intensive, you need to replace that appliances. So there you have to recommend what would be the payback for that if you replace that appliances, and cost benefit analysis, because all these your industrial people or commercial, always they focus towards the techno-commercial aspects of that your all the implementation. So that we need to do, and at the end we have to prepare one action plan to reduce the energy consumption. That means the definition of the energy audit as per the EC Act says that you have to verify, you have to monitor, you have to analyze use of energy. Once you get comprehension about all these types, then you have to prepare a report. There you can recommend the different types of appliances changes or energy conservation measures, and you have to prepare a report, and you have to do the cost benefit analysis, and that you have to submit to the company. Now this energy audit, it is being divided into the 3 parts. Earlier there were only 2 types of the energy audit. Now they have categorized, added one more. So first one is the preliminary energy audit, or it is also called as a walkthrough audit. Second one is the targeted energy audit, and third one is the detailed energy audit. We'll see this, the methodology, how to conduct the energy audit, and then we'll go to the one case study. So under this preliminary energy audit, that means here we are not measuring anything. Walkthrough means just you have to take one walkthrough inside that industry, or inside the college also we can take walkthrough, and by that we can identify the scopes for that preliminary energy audit or the energy conservation measure. So what is done under this? It is very quick exercise. Under that, just you have to collect energy bills or the invoices. Energy bills mean directly will get from the discoms, and invoices, suppose you are purchasing LPG gas, that you know that how many per year, how many cylinders you are consuming if it is for the residential. For a college, how many cylinders are being used for the canteens or hostels. For industries, how many tons of the coal is being burned, firewood is being burned, and that just data you have to collect, hard copy or the soft copy from that particular agencies or the organizations, and on that you can establish energy consumption in that organization. That means per year how much is being electricity is being used, how much is coal is being used or LPG gases, and on that basis you will come to know that what are the potential saving opportunities in that particular industry, that is estimate the scope for saving. So that with the analysis, with some experience, you will get idea about once you take the walkthrough and if you go through this your electric bills or invoices, you will get idea how much percentage of that energy can be saved with some measures. So this is second. Now next type is on the basis of that analysis or the potential scope. Now you can decide there are some areas where without any investment also you can conserve the electricity. For example, if you go to any industry, the compressed air is being used for the cleaning cloths and body, as at so many places it is being wasted. Just you have to instruct that company people don't use, take care that it is being, it will not be wasted for the cleaning and other applications. Wherever there is a scope for the, you can make up of the lights, tube lights, fan, AC, wherever possible it can be done. Even for the compressors, sometimes what happens, the required compressed air, if it is required at a 6 kg per square cm square or the 6 bar, but it is being produced or compressed at around 8, 9, unnecessarily it is being done. So even if you reduce 1 bar pressure, tremendous amount of electricity can be saved per annum. So like that you have to take the different actions, and accordingly that you have to suggest to that company. Even as already I had suggested about the air conditioning or the leakages are also there, so it can be done. Now next is identify immediately no low cost improvement saving, that identify, you can inform to them, and set a baseline. That means for the particular industry there is a limit up to what you can reduce it, or up to that reference point you can decide. So that you have to do, and identify areas for more detailed study in this measurement. On the basis of this your preliminary or walkthrough, you can suggest to that industry or the organization whether they want to go for the targeted kind of the energy audit, or they need to go for the detailed energy audit. So this is very simple type of the first type of the preliminary or walkthrough energy audit. Now second, what happens when we do that preliminary energy audit, there you may found, or the organization owners may say that we want to do only that audit for the lighting system, audit for the boiler, audit for the air conditioner, audit only for the compressed air. Then that come under this your targeted energy audit. Here in the second type, we go for the measurements. With the help of the instrument, we measure all the things. Even for the lighting system, in most of the cases, suppose if you take example of the jewelry or example of the some suppose showrooms, where unnecessarily this showroom is being illuminated with more appliances or more tube lights or the LED pictures and other things. So there are some standards for the particular that jewelry shop or particular showroom, how much lumens is required. There are some standards as per this your government, or there are some codes. So that we need to emphasize, we need to bring to their notice that this is required and you are utilizing this much, or there we can suggest to change energy intensive all the types of the appliances with this. Even for the boiler also it happens like this, compressed air also happens like this. So this come under the targeted. This is only a small list, but anything can come under this your targeted energy audit. So these are the two types of audit. Now third important is detailed energy audit. So this methodology is given by Bureau of Energy Efficiency. Now in the detailed energy audit, it has been divided into 3 parts. So first is called as a phase 1, that is a pre-audit, or you can treat it as a walkthrough audit. Pre-audit or it is a walkthrough audit, as good as what we are discussing that type of the audits. Second one is the audit. That means actually you have to perform, you have to conduct, you have to read the different values from the industry with the help of the different instrument. And third one is a post audit phase. That means you have to do analysis, and that you have to submit that analysis or report that particular management, and implementation has to be done, that all the cares will be taken. So this is the it is 10-point methodology as per the Bureau of Energy Efficiency. Now we'll see one by one. So step one, that is, it come under the pre-audit phase. So step one is plan and organize walkthrough audit. Just I had mentioned about how to do that walkthrough. And here informal interview with energy manager production inside that people's, because whenever you go to any new industry, actually we want to understand what type of the production, what type of the consumption they are using, what types of the energy they are being used inside that particular industry. So for that, initially some preparation is required. So this your first step is just for the preparation or the arrangement of the all the instrument. So here you can do one thing, establish or organize an energy audit team. From there you can identify people and you can start the energy audit establishment of the team. Organize instrument and time frame. Sometimes when you take the visit there, you will come to know that what type of the instruments are required. Now their time frame, how many days you need that instrument, because that is that planning need to be done. So for that, this first step is there. Next one is the macro data collections. Macro means just we are not going in depth for any kind of the consumption, just we are collecting all the information, collecting in terms of the electric unit consumed throughout the year. Other invoices, might be the coal, might be the firewood, might be the LPG gas, whatever the different types of the electricity energy is being used, that all the data that we are collecting, and familiarization with the process and plant activities, because we need to initially understand what is the raw material and what is the output or what is the finished product, what type of the processes are being done inside that industry, that we need to understand. So that is, for that, this is first step is there. And first hand observation and assessment of current level of operation and practices, at what level they are operating, what are their best practices, what they say their best practices, that everything we need to understand as a team. Just we have to go with the blank and just we have to observe without any bias. And every industry is different. For the same type of industry, if you go to other industry, there the methodology, there the procedure, entirely it is a different. So in the first step, just it is a preparation. Now second step is introductory meeting with all divisional heads and persons concerned with the energy management. So it is expected that 1-2 hours you should have interaction with that. This is just to create awareness about the this energy audit, to build up cooperation and rapport. Otherwise, all these your people will feel that the team has come, they are doing something, they will blame on us. We are not utilizing properly that energy or the method process. So for that, we need to create proper rapport between that our team as well as that in the energy management or the professionals, those who are working. Second one is orientation and awareness creation, that we need to create awareness, why it is essential, how much would be the benefit, what would be the rewards to you. And we have to prepare questionnaire for the particular type of the operation or process or that particular industries, or even for the department also, that we can give the different application to a questionnaire to different. So this is the second step. Now while moving to the third, that is on audit phase, that is second phase. Now we'll see what are the different instrument you need to carry, because when you took as a during the pre-audit phase, your mind is prepared to carry some of the instruments. So these are some of the minimum instrument which you need to carry to conduct the energy audit. So first one is the anemometer. So in most of the places you need to measure the velocity of the air. And once you get the velocity, then other so many parameters. This is basically required for the ventilation, HVAC applications, ducting, wherever duct is there, the fluid air is flowing. So here we can use this your anemometer, and that is very much essential, this instrument. In most, even if you go to the boiler, ID, FD fans are there. So how much air is entering to the through the ID, through the FD. So everywhere you need this your anemometer. So all these instruments are compatible with the computer. It has own memory, and if you connect to the computer, you will get in terms of the Excels. Second one is the ultrasonic flow meter. So this your ultrasonic flow meter it is a non-contact type of the flow meter. By that we can measure the flow of water or the flow fluid also. Other fluids also can be milk and others also measure with this your ultrasonic flow meter. So this is also most of the time essential while doing the audit of water audit. Suppose the pump is of the 10 HP and the pump has some specification, design or operating parameter, how much flow it should have. But actually nowhere nobody measures the flow of the water flowing through the pipeline, that because of the rusting, corrosion, so many issues, there is a drop in the discharge of that your pump, that water. And pumps are getting old also, motor has issues. So with the help of the ultrasonic flow meter, we can measure actually the flow of the water. Now another one is the flue gas analyzer. So this your flue gas analyzer is used to measure the combustion of the fuel burnt inside the furnace or the boiler. So there is one probe, just you have to put that probe in the chimney of the boiler or the furnace, wherever which type of the fuel is being used. On that basis, that setting has to be done. And directly with the help of the flue gas analyzer, we'll get all the compositions inside the flue gas. It may be SOx, it may be NOx, carbon, oxygen, O2, carbon dioxide, carbon monoxide. So many things the data will get from this your flue gas analyzer. And with this data, then we can calculate or we can estimate boiler efficiency by indirect method. So this is very good instrument, which is essential for all the thermal application. And another advantage is directly it can be connected to the computer, so that data can be taken in the Excel and it can be analyzed. Another one is this is power analyzer. This is very important, essential instrument as far as all the electricity measurements are required. Through this your power analyzer, it can be used for the single phase or it is for the 3-phase. For the 3-phase, you will get all the 3-phase voltage, 3-phase current, power factor, harmonics, kilowatt consumption, reactive power, active power. All the parameters you will get from this your power analyzer. You have to just connect in the proper way and you have to measure the pattern, consumption pattern, how it works. That everything will get with the help of this your power analyzer. Now this is the temperature gun. It has become so popular because of the COVID, everywhere that we are measuring the temperatures. So in similar way, it is essential to measure the temperature of the number of the appliances. So this is a temperature gun. And in addition to temperature gun, nowadays we have purchased another instrument, state of art, that is a thermal image. Here you will get the temperature at a point, but with the help of the thermal image, you will get a thermal image or you will get contours that what is the temperature on the outside surface of the motor, on the different pipes through which the hot fluid is flowing, steam is flowing, because this will give idea about the machines, motors, at what temperature they are working. For electric, especially for the electric motors, if the temperature gone increasing, it will affect on the insulation inside the motors and life get drastically reduced. So here these thermal images are very important. And another one is this hygrometer. It is essential for all the HVAC applications. Whenever we are auditing about the HVAC system, bigger HVAC system, it may be centralized or the package time. Inside every room, we need to understand what is the temperature range inside the room at every 4 corners. So similarly, you can put the 4 this hygrometers inside the room and automatically you will get the data for the 24 hours, and that you can analyze with the help of this. So these are some of the minimum instrument. Other than also we need instruments, but with this you can start the energy audit activity. Now after that we'll go directly to the phase 2, that is actual audit phase. So here we'll go with the preparation with the team, with all the instruments having charged and everything, instruments are ready. So this is the main is the primary data gathering, process flow diagram and energy utility diagram. So here what happens, because every industry is different, there we need to understand the different line diagrams, single line power distribution diagram, because that electricity comes from transformer at one place, from there it is being distributed at a number of the places, how it flows, where are the different points where we can measure. This is about electricity, this is about the steam, this is about the water, all the single line diagram that we should have. If suppose that data is not available with that organization, we need to prepare the data. Unless and until you get all this your information, it is very difficult to audit or heat balance or the mass balance for the particular applications. So here it is again compressed air steam distribution, because what happens, how much steam is being produced or generated from the boiler and where it goes, or how much water is lifted from the pump and where that water goes, air. So that is very important in this case, and for that we are referring the manual logbook. In some of the industries logbooks are there, and even it is being put on the nameplate. So that everything we need to verify, and that data analysis, that actually it starts from the third. Now fourth one is the conduct a survey and monitoring. So here actually the measurement starts. So in the measurement, now motor survey, even in some of the industry, what happens of the same company, same capacity kilowatt or HP, number of the motors are available. So that you need to separate that list, identify the different types of the motor, different types of the compressor, different types of the all other appliances that you need to segregate. And on that basis, then you can decide where to measure, how much time we need to measure, because there are some of the appliances, they are continuously consuming the same, they're extracting the same. There are some VFD kind, there is a variation in the consumption. And even the lighting survey also, how many tube lights are there, how many fans are there, how many street lights are there, whether it is essential, that all the data that we need to take, that come under the step number 4. Now next step number 5 is conduct of detailed trials. So here in the step number 4, we can take the measurements, but there are some appliances, some equipments where you need to conduct the trials, which are in our curriculum: trial on the boiler, trial on the air conditioning, trial on the refrigerator. Like that, here we need to conduct the trials, we need to monitor that particular equipment for 24 hours, for 8 hours. That depends on the type of the consumption pattern. So that we need to do all these things. So there, even for the particular that building or the industry, once that inside all the details is over, we put that power analyzer to the main supply where electricity comes from the transformer, and there we'll put this power analyzer for 1 day or the 2 day. So for the throughout the day, 24 hours or the 48 hours, you will get the consumption patterns, and that patterns are very much essential, useful for analysis of this your energy audit data. So that trials, that timings are also different. Now next is 6 number, analysis of energy use. Once the data is gathered, now there you need to balance, that is energy and material. So how much material comes and what is the weight of, or in and out of the material. You can call in and out, or that you can take examples of the how much water comes from the bore well and where it goes. That balance has to be there. Similarly, how much electricity comes from this one side, how much is the out, where it is being consumed. Similarly, coal, how much coal comes in tons and where it goes, how much it gets converted. So all this you need to analyze, and by that you will come to know that energy as well as what loss, wastage, that you can identify with that analysis. Now 7th step is, after completion of all, the next important is ENCON, or identification and development of energy conservation opportunities. With the data, all this up to the 6, whatever the data gathered, whatever the readings we took, what analysis we did, on that basis of the analysis, now you have to decide what are the options, energy conservation measures, how we can reduce the energy consumption. So for that, you can conceive, develop and refine it. Continuously, you have to reiterate, think on that continuously, what can be done, 1, 2, 3, 4 options. Ideas also suggested by the unit persons. Sometimes in that particular industry, some people also suggest. From our team, somebody will suggest. So that is also very important. In some of the industries, suppose earlier somebody has done the energy audit, that reference you can take. Even a brainstorming session, value analysis techniques can be used. Even what happens in most of the industries, continuously innovations are going on. So you can ask that industry persons, do you have any other appliances or the equipment which is energy efficient than the earlier? So like that, on that basis, we have to prepare the energy conservation measures. Now next one is the cost benefit analysis. Suppose once you identify, you want to replace some compressors, some motors, tube lights, fan, air conditioners. The next thing is you have to do the cost benefit analysis. What would be the payback for that? If I suppose replace that motor, if I replace that fan or the compressor, all the appliances, HVAC system. So what would be the cost benefit analysis or the payback period? So that is very, very important. Once it get finalized, next step number 9 is reporting and presentation to the top management. So whatever the data, whatever the energy audit analysis we understood, that we need to convince the top management. So their documentation, draft report, presentation to the top management, and on their input. Suppose you have suggested 4, 5 different measures, they will say to modify it, or they will say to reduce it. And finally, we'll come up with some solution that this much can be reduced. Then final report preparation on feedback from unit. So then you have to prepare final report on the basis of input you received from the organization or the top management. So up to this 9th is over. Now last post audit phase, that is implementation and follow. Because what happens, you submit report, the organization ready accepted that report, but what next, that whether they are implemented, whether it is being operating properly, that follow is very important. Implementation verification is important. So that is also our responsibility, and as per the action plan submitted by us or schedule for implementation, and that we need to monitor periodically. You need to visit, your team members should visit that particular industry and measure or verify that the data whether it is as per our expectation or not. So these are the 10 steps, and this is common. These all the 10 steps are common for any type of the energy audit. It may be from home also, you can start, commercial building or industry, any type of the small or the bigger industry. So this is about what I wanted to brief about how to do it, and starting from the energy scenario to the types of audit and the methodology. Now I will share one case study of one of the engineering college. Purposely I have removed the name of the engineering college, and here you will get the feel of the energy audit report, how it looks, what are the different types of the calculations are involved in this energy audit. So the title would be like this: energy audit options at a glance and the recommendations. So like this, we prepare the report and we submit, we present in front of these peoples. Now here always we emphasize, we take all the references of this your Save Energy program of the MEDA, Maharashtra Energy Development Agency, and other things, and as well as this your Bureau of Energy Efficiency. As we are taking this reference because our institute is empaneled with this Mahaurja, and that all the organizations, they are getting 50% incentive from the your Mahaurja if you submit that report as per their the guidelines. Now this is energy audit options at a glance and recommendations. Now for that particular engineering college, now here this left side is the highlights, and this is the impact of the proposed energy conservation measures. So what is this highlights of this your report is total annual saving in terms of lakhs. It is 38.87 lakhs would be the saving if they implement as per our recommendations. So this much is saving for that particular engineering college. Now total investment would be around 61.85 lakhs rupees. Okay. Now what would be the payback period for this particular investment and saving? It is 1.6 years. If suppose they invest around 61.85 lakhs rupees as per our recommendation, they will save per year around 38.87, and payback period would be a 1.6 years. Even if you consider the 2 years is the payback period, after 2 years, every year they are going to get this much is the benefit. That is a saving in terms of the consumption, either electricity or other types of the consumption. So this is, now here the details are given. Now next is electric energy drawn from the MSEDCL, that is Mahadiscom. So they are taking lakhs of electric units, that is 8.06 lakhs of electric units being drawn from this Mahadiscom company. They have solar system also. So electricity generated by solar PV is around 1.49 lakhs kilowatt or electric unit. Electricity generated by AC genset, they have generator. Now this is approximate figure, that is approximately 4 hours per week. As there is no any load shedding and other thing, so only this much amount, around 21,000 electric units are being generated from this your genset. So actual annual electricity consumption in terms of lakhs of electric unit, that comes as a 9.76 lakhs of electric unit that in particular institute is being consumed. It is consuming per annum. Now another is LPG consumption. Approximately at some of the hostels they are using LPG to heat the water. So that is around 15 ton. This much is LPG gas is being consumed. Now annual electricity cost. So if I consider this total electricity 8.07, so it comes as a 114 lakhs. That is 1.14 crores of the money spent on the electricity cost. Diesel it is very small, that is 2.50, and LPG it is around 9.84 lakhs. So total their energy consumption, cost of for the energy, that is around 1.26 crores. This much is a yearly consumption for that your particular engineering college. Now what is impact of proposed our energy conservation measure? their electricity consumption, that is saving it is shown as it is around this is 3,32,683. This much unit of the electricity is being conserved with because of our measures. So that comes as a 34%. Here it happens because this institute is very old. All the appliances, maybe electric, that fan, tube lights, air conditioners, motors, all are old one. That is 10, 15 years old one, as it is a government institute. So here the percentage that is saving is more. But in other cases, it may be 20%, 25% or 15%. Even 10% saving is also better. It is a reasonable. Now estimated annual cost reduction, it is 30 lakhs 0.87, and simple payback period is this. So this is the outline or the highlights of our summary, because once they convinced with this highlight, then and then only they are ready to read our report. So for that we have extracted all the data on the executive summary. Now how that figure comes, so for that again details are given, and further details are given in the further tables. So here it is, we have recommended that replacement of the fluorescent tube light to LED tubes. The total number what we have recommended is 1,630. No doubt that college has around 3,000 tube lights. Only we have approximately 3,000, that number is different. So we have recommended only 1,613. So even suppose if they replace this 1,630 from FTL to LED, so per annum that saving is around this much in terms of the electric unit. Okay, so what is annual saving in terms of the money? So this is around 10 lakh. So investment is around 11 lakh. So what is simple payback period? It is a 1.12. Now here we have taken how much is the reduction in the carbon dioxide emissions. So this much metric ton per year would be saved only by the replacement of this FTL to the LED. Similarly, replacement of existing pump to energy efficient pump. We have recommended only 7 number of pumps which are frequently used to lift water from one place to other. So because of that also, how much electric unit is saved? This is annual saving is around 30,657 electric unit. In terms of money, approximately it is 10 rupee per unit it comes. So investment is 2.8 lakhs and payback is 2.11, and this much is the reduction in the carbon dioxide emission. Even we are recommended to replace the existing ceiling fan. Here number is 707, but actual fans are more than 1,500. We have recommended only this much they need to replace. So how much is the saving? Is 89,000 electric unit is saving. So how much is the saving in terms of the money that is taken here, and investment, because this energy efficient fans are a bit costlier as compared to the regular fans. So the payback is 2.61. Again, here carbon dioxide emission, this much is the reduction. Now even there we have recommended solar water heater, because in hostel they are using electric coils. So this much is the saving in terms of the electric coils. In electric units it is 1,30,000 something, and monetary saving because of that this savings. So investment is also taken. So the payback period is 1.28, and how much is the reduction in the carbon dioxide? Even they have old air conditioners, because for the server it is expected that the air conditioner should work for the 24 hours, and every department has a servers. So we are recommended to replace that server, some of the energy intensive air conditioner, old one without any star labeled. So that is a saving this much. So the payback is bit higher compared to this, and reduction in carbon dioxide. So total it is like this, total saving in terms of the electric unit, in terms of the money and investment. So total payback comes to be a 1.6 year, which we have taken on the highlight page. Now again, we do analysis of all the electric appliances or the bill, what is the bill, their bill analysis. Electric bill analysis is also very important. They have different types of the electric meters. This consumer number is also given. So these are the tariff patterns. Always it is very important to understand the reading of the electric bills, because the electric bill reading is different for the different types of the consumers. The tariff wise it is different given. So what is contract demand is also very important. Connected load for that particular motor, how much it is also important. Now what is demand charges per this your contract demand? That is, there are some provisions up to what percentage, that depends on type of the consumer. It is not for the residential. For for the industry, different types of the categories, the demand charges are different. Energy charges, that means only we know that energy charges. Always we remember that is at home, that is initially it is a 3 rupees, after that it is 7 rupees, 9 rupees. But there are some hidden charges that also we need to understand, and the billing charges. Now this billing charges means whatever the electricity transmit from generation to the distribution, for that they are putting these charges as the billing charges, and this amount goes to the Vitran companies. So like this, these are the three different meters. Now AC genset, they have this genset of 125 kVA Kirloskar band and solar PV system. Now again here we will get the detailing about this. These billing charges depends on the type of the supply voltage 33, 22 and this. And another important for the industry that we need to understand the consumption pattern, and the billing is done on the basis of a TOD, that is a time of day. Now here we can see the time of day, what happens whenever electricity is being consumed at night 10 to morning 6. We'll get rebate of 1.5 rupees per charge. That means suppose the rate is 9.7 rupees as energy charges per kilowatt hour, and for night usage you will get less this. That means you can reduce this 1.5 from the 9.7. So that is a benefit if you use more electricity at night. So that is called as a demand side management. Here you can manage your requirement like this. Now another one is electricity used, consumed between morning 6 to 9 and 12 to 8 day. So there is no any change, addition or the less, that whatever is claimed, that is 9.7 would be here. But if you use electricity between morning 9 to 12, so you have to pay extra 80 paisa on this. And if you use electricity at evening peak hours, that is 6 to 10, here you have to pay, that is 1.10. So at industry level or at a consumer side, always you need to balance that use of that appliances, so that you will get the benefit of this your 1.5 paisa or this, or unnecessarily we have to pay additional charges for, because at evening 6 to 10 the requirement is very high. They treat it as a peak load requirement, where they have to operate different types of the power plants here in order to fulfill the requirement of this. Now like this 1 year, generally it is expected that we should do analysis of electric bill for the 3 years. So here we have done for the, we are doing also 3 years. So here for the sake of your presentation, here I have taken only for the 1 year. So we have to collect all this your electricity bill. We have made this your Excel sheet, and here you will get idea about the consumption pattern. Now earlier there was, before this your 1st April 20, earlier there were incentives for the power factor. So every owner was trying to bring that power factor to 1. Nowadays that they have removed that the incentives, but you need to maintain the power factor, otherwise the cost will increase, because earlier the electricity energy charges were on the basis of the kilowatt hour. We have seen this it was on the basis of the kilowatt hour, that is 9.70. Now instead of the kilowatt hour, they have brought to the kVA billing. So how much is the kVA, kilovolt ampere, on that basis, because always kVA is higher than the kilowatt hour. So that happens because of this your power factor. So nowadays the electricity bills are getting enhanced by 10-20% because of this your power factor. So you need to focus on this your power factor. So these are all the hidden component, we never bother about it, and because of this your hidden component, electricity tariff goes 10 rupees, 12 rupees, that depends on the type of the consumer. Now then we do the analysis of this, what is between the contract demand, highest recorded demand and bill demand, and on that basis we recommend that industry, that owners, that how you can conserve the electricity. Now here this pie chart will show you that is here, out of that 100%, 63% is energy charges, and all these charges are depends on this energy charges. If you conserve the electricity, automatically this get reduced. So accordingly we suggest them to reduce the consumption of this your kilowatt hours. That means automatically these all the components gets reduced, and always it is better to take the benefit of this for a power factor. Now always it is expected that power factor should be 1, but you will find that here in for this your particular college, at most of the places the power factor is far below than this. So because of this, actually, that college has to pay that penalty for this your power bank. Now, next step, we do the inventory. We collect the inventory of the gather inventory of the lighting system. So here for that particular building, now how many electric appliances are there? LED are there, T12, T8, T5. So accordingly, we prepare this your inventory. So this is total now LED tubes. Already they are 266, but T12 tubes they have 1000. T8 that 381. Like this, that we gather all this your information. Similarly, for the fan also, they have the fans total this much, wall fans this much, table how many, pedestal, exhaust, all the data we need to gather. Even for the ACs also, as at our place that much requirement is not there for the air conditioner. So here you will found the count is very small as compared to your place, and PCs are around 1974. I will elaborate only one and then I will hurriedly move to the other side. Now, how that lux level analysis is done at a particular sections. Now, suppose if I take the one section that is a geotech lab, okay, geotechnical lab. So here we take that all the dimensions. So length, width, mounting height, where that tube lights are being fitted. So the floor area automatically will get from this side. Now, room index, there is one standard on the basis of length, width, and height. We have to calculate the room index. And the room index gives idea about at how many points we need to measure the lux level. If the size go on increasing, the number of the points for the lux level go on increasing. So for that, we need to calculate the room index. Room index has the only significance about the number of points where you need to measure the lux through the lux meter. Okay. Now next is total circuit wattage. So suppose for this it is 360 watt comes. That means how many tube lights are there fitted inside that particular laboratories, that total summation of all. Suppose one tube light is of the 40 watt, that means 40 watt multiply the total number. So here it comes as a 360 watt. Now then we used to calculate watt per square meter, because we know the square meter, that is area. So how much it comes? So watt per meter square, it comes as a 3.8. That means for the particular laboratory, the per watt per meter square, 3.8 is the consumption. This much is the connected load, or you can say it as a connected load. Now average maintained illuminance, that is a lux level inside the room, that is a 280. That is we have measured on the basis of this room index. So at a number of the points, it comes as a 280. And actual lux per watt per meter square, there is one formula. Here you are getting all the data. So lux per watt per meter square. So it comes to be a 72.83. But actually, as per the standards, how much it should be? It should be a target lux per watt per meter square for the particular type is 48. That means in that particular laboratory, unnecessarily they have installed, fitted more number of the tube lights here. So here this your installed load efficiency ratio, ILER, is very important. It should be up to 1. It should be up to 1, and 0.75 to 1 is the best. That is the excellent or the good one. But here what happens? Here it is more than 152. So we have recommended to reduce some number of the tube lights, and by that they can reach to the 1, and automatically their electricity consumption get reduced. Similarly, we have calculated this ILR for all this. For the time constraint, I will skip all these things. Now suppose energy conservation measure for the particular tube lights. Now for the geotechnical, we'll see for that particular labs. Now here this is total target, as already we have seen this ILR is, this is, now it is suppose 1.33. Annual working hours, here we have considered as a 1400. That we have to consider on the basis of the usage of that particular building. If the building using, whether daily usage is 6 hours, 10 hours, that depends on the type of the application. Here it is considered on the basis of the discussion, it is a 1400 hours per year. Now energy, existing energy consumption, by considering this 1400, it comes as a 504 electric unit per year. Now proposed energy, now we are going to replace that existing energy intensive, that tube light, with the energy efficient. So it gets reduced to 308. Earlier it was consuming this much. If they replace as per our recommendation, it will come like this. So annual energy saving would be around 197 kilowatt hour, or this is the electric unit and energy tariff is 9.7 rupees. So saving is 1900 and this. So total appliances is this. This is we have calculated for one. So total investment for 22 watt LED tube light. Here again we have considered purposely higher size by considering the some breakage or some warranty period like this, by considering expected life. Even here the life comes to be a 3.68. Like this we have calculated. Now same for the, now here 78 means it is better, 29 it is less, that means we have recommended them to go for the additional tube lights there. Generally the payback should be below 3 years and ILER should be above 0.75. If it is below 75, we ask them to add the tube lights. If it is above 1, we ask them to reduce the tube lights. So for every lab, we used to do that analysis and accordingly we submit to them. Now we'll go to the another appliances. Now next is about ACs. They have number of the ACs. So these are the data from the table. Now voltage, current, power factor. So everything that we have tabulated from them. Now again here you can see these are the old, that is power factor is 0.98, 92. It is 0.864. Here the power factor is very less, that is 0.44. So these all the data need to be collected. Now water pump. Now again we do audit for this water supply. That means how many number of the students as well as faculty are inside that your campus, and what is the consumption of water, because there are different norms for the water consumption. Now here we do the such types of the line diagram, because as they don't know, it is old college. So we have prepared this your schematic of this water pumping or supply arrangement of the system. How many pumps are there, how the water comes, from where it comes, how they are lifting water, and from the storage, how it goes to that number of the application. Even they have made one for the potable application and another one is for the other applications. So this is, it goes to the overhead and then it is being distributed for the all the. So like this we prepare for the drinking also. Now here there are different types of the pumps. Now suppose on this data is taken from the nameplate. So here it is a meter cube per second, 0.0016. Head, how much is his for that particular application. Pump rating is what is this, speed, what is speed of the pump, motor rating, motor efficiency, combined overall efficiency, because motor plus pump, and motor input power. Now here you can see this is the 2.28, this is the input, that is motor input power for this, and we'll see that after replacement what happens for that. Now similarly for the different types of this your pump, these are the pumps. So we have gathered all this your information. Now again next is about the hostel details. How many hostels they have, how many geysers they are using. This all the data is very much essential. Now we'll see for that particular pump. Now suppose this is this flow rate, it is meter cube per second. For the Kirloskar it is 0.0016. Total head develop is 26. Motor input power is 2.28. Now we have recommended them as a Grundfos pump, submersible type. Flow rate is, this is 5760. So head is same head. Now power consumption would be 1.375. Earlier it was 2.28. That means estimated power saving would be around 1 electric unit or 0.9 electric unit. Annual working hours we have taken it as a 1800. Annual power saving it comes as a 1629. Tariff is this. Estimated annual cost saving is 15,000. And investment for this energy efficient is 24,000. So payback is 1.5. Similarly, we can do for the other pumps also. Now this is example for the fan. So they have existing fan here 368, 339 and 342. Now existing wattage of the fan is 75 all places. Usage of fan per day in hours, here administrative all this is 8, hostel it is 10 hours and it is 4 hours others. So this we have considered major because number of days per annum 300 and 300. Total kilowatt hour consumed, that is electric unit consumed by existing fan per year by considering this 300 year and this number of fans plus this capacity. So it comes to be a 66,240. Similarly, we have calculated for this. Energy consumption bill for installed fan, it is 6,42,000. Now we are recommending to replace this 75 to the 28. So wattage of energy efficient fan is So this is total, it comes this much. Total kilowatt hour consumed per year by energy efficient fan is 24,000. Saving in kilowatt hour, so this much is saving, 41,510 electric unit is saving. Energy bill for energy efficient fan is this much, 2,39,000. Saving in bill using energy efficient fans, this minus this, it comes as a 4,02,650. Cost of fan we have considered as a 3,200. Total investment is 11 lakh, but payback is only 2.9. That means after 3 years, this much is the saving. Continuous, it is a saving. 4 lakh is a saving. Now similarly for hostel also, that we have calculated, because of this 8 to 10 years, 10 hours. So this your payback get reduced. But here we have not recommended, because this usage is very small. If you replace unnecessarily, so the payback goes around above 8. So we are restricting that payback maximum up to 3, good. Or in some cases, if the appliances are old and other things, then we allow them to go up to the 5 years. Now similarly we have done for the AC because of time constraint. Now another one is the replacement of electric water heater with the solar water heater. Now this just I will share this case study. Now here this is electric water heater capacity. So they have 2 kilowatt coil into 12 number. So this is 24,000. Efficiency of electric geyser is 85%. Number of boys 467. Hot water requirement we have considered only 1 bucket of hot water. This is 9,340. Always there are some losses, 10% consider. So suggested solar system is 11,000 capacity. Heat required here at thermal, we did the calculation. Heat required to raise the temperature of this 11,000 from 20 degrees Celsius to 50 degrees Celsius in kilojoules per day. So it must, this much comes. Heat energy required in kilowatt hour. Suppose this much electricity, kilojoules heat energy required. How much electric units are required? That we have calculated. So heat energy required in kilowatt hour per day. So that comes as a 320 electric unit. That means what happens? 1 kilowatt electric coil gives you 3,600 joules. So on that basis, this we have calculated. Now electric energy required in kilowatt hour per day, considering efficiency, because efficiency of this is 85%. So it comes to be 376. Cost in rupees per electric unit is 9.7. Cost in rupees per day. That means that particular hostel is consuming, spending around 3,650 rupees to heat the water. Total working days in both semesters we have considered only 200, 90 days like this. Cost in rupees per annum, it is 7,29,000. Now payback calculations. Total investment for this or particular is 11 lakh and payback year is 1.51. So like this we have done for the combination of this or LPG. Also suppose they don't want to invest immediately 11 lakh. Then we have given other combination 30, 20, 30, 70 like this, 30 electric and 70 gas. Like this we have done this. So these calculations are like this. So many are there, but I think it is better to have some question answer. Over to Kai sir. Hello. Hello. Hello.
हाँ sir, just a minute.
Yeah, please.
Hello.
Yeah, please.
Question for the participant. Hello.
Yeah, please.
May I audible?
Hello.
Hello.
Yeah, please.
Am I audible?
Yeah, yes.
Hello.
Yes, audible, sir.
There's one question: how to become energy auditor and manager?
Okay. For energy.
Hello.
Total, there are 4 subjects. If you qualify 3 subjects, you become an energy manager. If you qualify the 4th subject, you become an energy auditor. For the first 3 subjects, it carries 150 marks with 3 hours. And last paper of the 4th energy auditor, it is of the 2 hour, 100 marks and open book examinations. And it is very difficult to qualify the last paper. And even earlier, there were no that much stringent norms for the experience. Nowadays, they are expecting that particular student after graduation, he should have worked in some of the industry or might be in some industries actually working experience related to energy for the 3 years for the graduate students and 2 years for the postgraduate students. And all the data that handbooks are available on this your BEE website, Bureau of Energy website. You can download that all the syllabus, handbooks, and everything. The questions would be from handbook itself. That's very particular. Only the level of the difficulty level is very high because they are expecting this is a professional examinations. Always they give the problems, real problems from the industry, and accordingly that we have to solve it. Please.
Hello.
Hello. Hello. Sir.
Yeah.
Sir, what is certification authority for it?
For examination.
Yes.
Actually, exam is being conducted by National Productive Council under the guidance of Bureau of Energy Efficiency. Bureau of Energy Efficiency has given that authority to National Productive Council, NPC. And NPC
Okay, sir. Thank you, sir.
Yeah,
Now
thank you.
I hand over this to Mukund, sir. Mukund, sir, please continue.
Yeah, it is my privilege to propose a vote of thanks on this occasion. I, Professor Mukund Valsi, on behalf of MCT Rajiv Gandhi Institute of Technology, Mechanical Department, and on behalf of Organizing Committee of AICT AQIS sponsored online 1 week short-term training program on recent trends in energy management and audit, and my own behalf, extend a very hearty vote of thanks to Dr. Sanjay Khot sir for accepting our invitation as a resource person and sparing his valuable time with us. He given very good insights on the topic of energy scenario, Energy Conservation Act 2001, energy consumptions by the building, energy audit definition and its type. Also, the methodology which consists of 10 steps. Also, the instrument used for the energy management, and he has covered a case study, right? Thank you so much for it, sir.
Thank you. Thanks a lot. Yeah.
Tomorrow, as on the 3rd November morning 10 a.m., we have the third session of this STTP by the Tushar Jadhav on the topic of energy saving in steam distribution system and utilization. I request all the participants to join the session. Thank you and thank you all.
Thank you. Okay. Thank you.